Hi everyone, welcome back. Now we'll be moving into a discussion about acid bases and the pH scale. So my preferred method of defining what an acid and a base is the Brownstead-Lowry definitions. And so by this I mean that an acid is a proton donor and a base is a proton acceptor. And in chemistry, when we talk about protons, what we really mean is H+. And so every acid, when we take away that H+, right? So acids take the general form of HA because it's H with an acid portion. And when the acid dissociates, it becomes the proton all by itself, or H+, plus A-. And now since we have this A- term, the minus means that it wants a positive charge to neutralize it. In this case, an H+. So now A- is the conjugate acid of HA, and HA is an acid that dissociated into H+ and A-. Bases tend to take the form of BOH. So a base term, B, and OH. And so when a base dissociates, it's going to give away an OH- plus a B+, B positive. So that B+ is now the conjugate acid of a base. It's an acid because it has that positive charge. So it's not going to want to have an H+ because that'll just give it a +2 charge, but it's going to want an OH- to neutralize it once again. And this OH- just so happens, it would be really happy if it bonded with an H+, right? So oftentimes acid and bases react together because when they dissociate, they can make water. H+ plus OH- gives water. And so this is the relationship between acids and bases. And so a pH scale goes from 0 to 14. And it's a general way we've accepted to determine if a solution is acid, or it has, meaning if it's an acid, it has H+ floating around, or if it's a base, meaning it has OH- floating around. And in the dead center is 7. So from 0 to 7, it's an acid. And from 7 to 14, our solution would be a base. And so we can relate acid and bases to the pH scale by taking the negative log of the concentration of the H+ concentration. So pH is equal to negative log of H+ concentration. Now, let's try an example using what we just learned. So what is the pH of stomach acid, a solution of HCl with a hydronium ion concentration of 1.2 times 10 to the negative 3 molar? So this one is pretty easy. They gave us already a concentration of H+, which is 1.2 times 10 to the negative 3 molar, and they want pH. That equation we just wrote relates H+ concentration to pH. So all we have to do is say if pH is equal to negative log of H+ concentration, we just plug in 1.2 times 10 to the negative 3. And for this, I get 2.92 for my answer. And that pH is way less than 7, right? Around here. So it means it's an acid, which makes sense because we're in stomach acid. So this checks out. So moving on, as we defined before, we just talked about pH scale that goes from 0 to 14. And now here is another example of calculating pH based on hydronium ion, where hydronium is that H+ ion. So you can try this one on your own.